Hi dear, today we'll learn about the power of a lens. Okay, so the power of the lens is given by converging or diverging capacity of the lens. Okay, how much it converges or how much it will diverge, that capacity of the lens is known as the power of the lens. Converging or diverging capacity of the lens is known as power of the lens. So it is denoted by the letter capital P. Okay. So this converging and diverging, how much it converge or diverge depends upon what? Your focal length, right? So based on your focal length only it will converge. See, look at this. So you are having a convex lens, principal axis, refractive axis, uh, parallel to the principal axis. The rays are coming parallel to the principal axis, right? It if your focal length is here means it will converge like this, right? Since it is parallel to the principal axis, it will pass through the focus point, right? Okay, focal point. So this length, the focal length depends on how it converges or diverges. See how much actually it is supposed to pass like this. So this much times it converges the light rays, right? This to this angle it is converging the light. If suppose the focal length is here means, see, look at this, the rays are coming parallel to the principal axis, so it will converge here. Okay, when compared to the first one, it is converging a lot, right? It is more, right? So based on the focal length only, the capacity of the lens is there, how much it is converges or diverges. Okay, so here the focal length is very less when compared to this. When the focal length is less, it converges more, right? The power of the lens is more and it will converges the light rays towards this focus, right? If the focal length is long, only slight converging of light rays is happening here. So this power of the lens, that is nothing but the converging or diverging of the light rays, depends upon the focal length. Depends upon the focal length. Okay, so this power of the lens is expressed in terms of focal length. Okay, so if it is focal length is more, you will get a shorter less converging. If the focal length is very less, we will get more converging. That means what? It is inversely proportional. That's why it is given as power equals to 1 by f. Okay, power is given as 1 by f, where P is the power of the lens, f is the focal length in meters. Okay, it is always substituted or entered in meters. The focal length is entered in meters. Okay, so what is the, for everything you will have some unit, right? What is the unit of this power? The SI unit of the power of a lens is diopter. Okay, diopter. It is represented by capital D. Symbol is capital D. Okay, this diopter. This power is expressed in diopters, right? So what is this diopter means? One diopter is the power of the lens whose focal length is 1 meter, right? So it is expressed in meters. Okay, this is expressed in diopter. So D is equals to what? 1 by m. So we can write it as 1 m to the power of minus 1. When it goes up, it will become inverse, right? M inverse. That's why 1 diopter is equals to 1 meter inverse, or meter to the power of m to the power of minus 1. So 1 diopter is the power of the lens whose focal length is 1 meter. Okay, for the focal length of the lens is 1 meter, you will get the power of the lens as 1 diopter. Okay, so in case of convex lens and concave lens, convex lens, in the case of convex lens, your focal length will be positive, right? So P is equals to 1 by f means you will get a positive value, right? P will also be positive, f is also positive. In case of concave lens, what about the concave lens? So you will get that. So it will diverges from where it diverges. It appears to diverge from the focus point, right? From the focus point. This is your focus point, right? So it is in the negative side of the x-axis. Okay, so if you calculate in the same way, you will calculate the power both in concave and convex. So P equals to 1 by minus F, you will be substituting, right? So you will get the answer in minus. So P is also negative and F is also negative in case of concave lens. Clear? So the convex lens, the power and the focal length are positive. In case of concave lens, power and the focal length are negative. Clear? So what is power of the lens? It is nothing but the converging and diverging capacity of the lens, right? It is expressed in diopters, because the SI unit of the power of the lens is diopter. One diopter is equals to 1 meter to the power of 1 by m. So it can be written as 1 m to the power of minus 1. 1d equals to 1 diopter equals to 1 m to the power of minus 1. That means 1 diopter is the power of the lens whose focal length is 1 meter. Okay. In case of convex lens, both power and focal length are positive. In case of concave lens, power and focal length are negative. Okay. Next, power of combination of lens. Okay. So when you go to the eye doctor, what they will do, if we are not able to get the image properly, we will have some problem. We'll go to the doctor and he will be testing with some of the lenses, right? In the spectacles, he will put some of the combination of lenses, right? And he will find the correct combination at what power we are able to get the clear image, right? Okay, in that case, we'll use the combination of powers, not only single power. Okay, combination of powers. So when two or more thin lenses are combined and used, then it's equivalent focal length. We cannot say the exact focal length, because 2 lens we will be using or 3 lens we will be using. How will you find the focal length? Combined focal length at 1 by f is equals to 1 by f1 plus 1 by f2 plus 1 by f3. It goes like that. Okay. Then how will you find the power of the combination? You can simply add that. Power of the combination equals to power of the first lens plus power of the second lens plus power of the third lens. It goes like that. Okay, simply we can add the power. So what doctor will do, he will keep one by one lens. He will check for the clear image, right? If you use 2 lens means, he will simply add the power of those 2 lenses and he will give, this is your power, so you are going to use this lens. Okay, this power lens. Okay, so he will he used like this. Okay, for the eye doctors will go for this, because it is easy to add like this. Okay, instead of mentioning through this focal length. In case of focal length means, we have to take the reciprocal and then we have to add, then we have to find the combined one. Okay, so they will mention the power in terms of only diopters. So it is easy to calculate the power, because we can simply add up these powers to get the power, what is the power is required. Okay, so uses of combined power. The simple additive property of the power of the lens can be used to design lens system to minimize certain defects in the images produced by a single lens. Okay, so instead of using a single lens, we'll go for a combination of lenses. Okay, we'll go for a combination of lenses. So these kind of system we'll use in camera, microscope and telescope. Camera, microscope and telescope. Okay, so how they are using, we'll check. For example, see here, for example, this is one convex lens with the focal length of, for example, this is 2 meters. For convenience, we'll take 2 meters. Okay, so this is your focal length. So light rays will be here. It will converge the light rays like this. Okay, it will converge the light rays like 2 meter. Okay, so if you are combining one more lens, for example, this is a lens, one more lens. For this, for example, this is 5 meter. Its focal length is 5 meter, means you will not get the focal length at 5 plus 2 7 meters. Okay, because it is inversely proportional, right? 1 by the combined focal length is given as 1 by f equals to 1 by f1 plus 1 by f2, right? When you are using one more lens, it again converges the light, right? See, now it is passed through this lens and it converges here. Okay, when you add one more lens, it further converges the light rays and you will get the focus point at this place. So your focus length, focal length will be reduced further. Okay, your focal length will be reduced further. We'll calculate this one. For example, 1 by f equals to, what is the f1? F1 is 2 meter. 1 by 2 plus this focal length is 1 by 5. That is equals to what? Here 10 is your LCM. So into 5 into 2, 5 by 10 plus 2 by 10, that is equals to 5 plus 2 by 10, that is equals to 7 by 10. 7 by 10, that is equals to 1 by f. Therefore, your focal length 1 by f is equals to 7 by 10. We will keep like that. Okay. Instead of doing all this thing, we can simply add up the powers. What is the power of the so if you substitute this, power is equals to 1 by f, right? 1 by f. F is given as 10 by 7. So that is equals to 1 by 1 into 7 by 10, that is equals to 7 by 10. Okay, your power will be 7 by 10. That means P is equals to 0.7, right? P is equals to 0. Power is 0. Okay, so since it is convex lens, it is plus 0.7 D. Okay, your unit is D. Okay, instead of going like this, you can simply add the powers. So what is the first power of the first lens with the focal length 2 meter? P equals to 1 by 2. 1 by 2 means 0.5 D plus 0.5 D. Okay, this is P1. What is the power of the second lens? 1 by 5. 1 by 5, that is equals to plus 1 by 5 means 0.2 D. What is the combined power? P is equals to P1 plus P2, that is equals to 0.5 plus 0.2 will give plus 0.7 D. So within 3 steps you are able to get the power of the combined lens instead of going like this. Okay, so usually doctors will go for the in terms of power only, they will prescribe the lens. Okay, not in terms of the focal length. Okay, if suppose for example, if you need some 20 diopters power to 20 diopters power to focus the image. Okay, but you are having only for example 17 diopters power. Okay, your eyes is able to your eyes is having only 17 diopters powers to get the image. Okay, so what he will do, he need 3 diopters to be added up. Okay, so he will put a lens with the power of plus 3 diopter. Okay, plus 3 diopter, so that you will get a combined power is 17 plus 3 is 20. So you will get the 20 diopters powers. So you will be able to see the image clearly. Okay, that's why they will go for giving the power giving the lenses in terms of the combined powers. Okay, instead of giving the in terms of focal length, they will mention in the prescription as in diopters only they will be mentioning. Okay, so it is easy to get like this. Okay, so this is how this power of combination of lenses work out, right? So I hope it is clear. So we in next class we'll see about the we'll see some of the numericals in the power of the lens. Okay, thank you.